In this example, we're asked to find the derivatives for the expression shown. So first we'll start with part A. So the function of x is x to the power of 7, and we're asked to find the derivative. So in this scenario, we'd have 7x to the power, and we remove 1 from the power, so that would be 6, and this will be our answer for part A. For part B, we have the function of x in x to the power of 8, so that would, the derivative will be 8, and we remove 1 from the power, so that would be 8 would take away 1, so that would be x to the power 7, and this would be our answer for part B. For part C, we have a function of x being x to the power 4, so the derivative will be just taking the power as it is, so that would be 4, and taking 1 away from the power, so that would be 4 take away 1, and that will give us 3, so the answer will be 4x cubed, and this will be our answer for part C. We're asked to find the derivative for the expressions shown. So first we'll start with part D. We have the function being x to the power of a third. So to find the derivative, we take third, x to the power third, take away 1. That would give us, in the scenario, minus 2 over 3. So this will be our answer, or we can re-express it as 1 over 3x to the power 2 over 3. So we can write our answer in either format. For part E, we have the function of x being x to the power of a quarter. So to derive this expression, we would have quarter, x to the power quarter, take away 1, that would be minus 3 over 4. So in this scenario, we can either write it as the format shown, or we can write it as 1 over 4x to the power of positive 3 over 4. So either way is a correct representation of the answer. For part F, we have the function being the cubic root of x. So you can write this as x to the power 1 over 3. So we better to represent it as fractions. Now to find the derivative, we would have third x to the power of third, take away 1, that would give us minus 2 over 3. So in this scenario, we can either write the answer in this format, or we can write it as in the format of 1 over 3 x to the power 2 over 3 in the positive power. So either answer is the correct formulation of the derivative for this expression. In this question, we're asked to find the derivative for the expressions shown. So first we'll start with part G. We have the function being f of x equal to x to the power of minus 3. So to find the derivative, it will be minus 3x to the minus 3 minus 1, so that will be minus 4. So this will be our answer for part G. For part H, we have the function of x being x to the power of minus 4. So to find the derivative, it will be minus 4 x to the power minus 4 minus 1, that will be minus 5. And this will be our answer for part H. For part I, we have the function of x being 1 over x squared, which we can write it also as f of x equal x to the minus 2. So now to find the derivative, we write it as minus 2x to the power minus 2 minus 1, that will give us minus 3. So this will be our answer for part I. For part J, we have the function of 1 over x to the power 5, which we can write it as x to the power minus 5, and the derivative can be written in the form of minus 5 x to the power minus 5 minus 1, so that will give us minus 6. So this will be our answer for part J. For part K, we have the function being 1 over root of x, so we can write root of x as x to the power of a half, and we can move this up, so that will give us function of x being x to the power of minus a half, So now to find the derivative, we have minus a half x to the power minus a half minus 1, that will be minus 3 over 2, which will be our answer for part K. For part L, we have the function being 1 over the cubic root of x, so that can be written as to the power of third. So we can have the function of x as x to the power of minus a third, because we move that up. So now to find the derivative of x, that would be minus a third, x to the power of minus a third minus 1. That should give us, in this scenario, minus 4 over 3, which will be our answer for part L. In this example, we have the functions shown, and we need to find the derivatives for the expression. So first we'll start with part M. So we have the function of m cubed multiplied by x cubed multiplied by x to the power of 6. So that will give us function of x being x to the power of 9. So now for us to find the derivative, we would have 9x to the power 9 take away 1, so that will be 8. So this will be our answer for part M. For part N, we have the function of x squared by x cubed, so that will give us x to the power of 5, because the powers will be added when they're multiplied, and in this scenario the derivative will be 5 x to the power 5 take away 1, and that should give us to the power 4, and this will be our answer for part N. For part O, we have a function of x being x multiplied by x squared. So when they're at the same terms multiplied by each other, that means the powers will be added. So that will give us function of x being x to the power 3. So now to find the derivative, we take the power as it is, which is 3, and we have x to the power 3 take away 1, so that will give us x to the power 2, and this will be our answer for part O. For part P, we have a function of x being x squared over x to the power 4. So to simplify this function, we move the x to the power 4 up, so that will give us x to the power 2 minus 4, which will give us f of x as x to the power minus 2. So now to find the derivative, we would have minus 2x to the power minus 2 and minus 1. That would give us minus 3, which will be our answer for part P. For part Q, we have f of x is x cubed over x squared. So first we move the denominator up, so that will give us x to the power 3 take away 2. So in this scenario we'll have the f of x being x. So for us to find the derivative, so f of x will be x squared. So we take away in this scenario 1 from the power. So since the power of x is 1, and take away 1, so it becomes x to the 0, so that means the derivative will be 1. So this is what will be our answer for part Q. Now for part R, we have the function of x being x to the power of 6 over x to the power of 3. So first we simplify the expression. So we move the denominator up, so that will give us x to the power 6 take away 3. So now the function can be represented as x to the power of 3. Now for us to find the derivative, that will be 3 x to the power 3 take away 1, that will be 2. So our answer will be 3x squared. In this example, we are given the expressions shown and we need to find the derivatives. So we start with part A. We have y equal 3x squared. So to find dy over dx, which is the derivative, we have the 3 remains as it is, and we take the power as it is, multiply by the power. And we take a 1 from the power 2, so we will have 2 take away 1, so that would be x. So in this scenario, we would have the derivative dy over dx as 6x, which is our answer for part A. For part B, we have y equal 6x to the power of 9. So to find the derivative, which is dy over dx, we would keep the 6 as it is, take the power, also multiply by it, and also we take 1 from the power, so we have x, 9 take away 1, so it will be 8. So in this scenario, we would have dy over dx being the multiplication of 9 by 6, which is 54, and we have x to the power of 8, which will be our answer for part B. For part C, we have y equal half x to the power 4. So the dy over dx will be to keep the half as it is, and we take the power and multiply by, which is 4. And now we have the x. The power will also be reduced by 1, so that would be 4 take away 1, so that would be 3. So now we would have 4 divided by 2, so that would give us 2. So the dy over dx will be 2x cubed, which will be the answer for part C. For part D, we have y equal 20x to the power of a quarter. So to find the dy over dx, we keep the 20, and then we multiply it by a quarter, and then we bring the x and we reduce 1 from it, so it will be quarter take away 1. So in this scenario, it will be minus 3 over 4, and in this scenario we have dy over dx equal, so the 20 divided by 4, that would give us 5, and we would have also the x minus 3 over 4. For part E, we have y equal 6x to the power of 3 over 4. So now to find the derivative, which is dy over dx, we keep the 6 as it is, we bring the 3 over 4 to multiply by it, and now we have the x with its power, so we reduce 1 from the power, so 3 over 4 reducing 1 from it, that would give us 5 over 4. And in this scenario, to simplify this expression further, so we would have 3 multiplied by so in this scenario we would have so the power is 5 over 4. So I've just made an error here, I couldn't see 12, so it's 5 over 4. So here we would have 5 over 4, and 5 over 4 take away 1, that would give us minus a quarter. So 5 over 4 take away 1, it would give us a quarter. And in this scenario, you can have divide both terms by 2, so that would be, you'll be left with a 2 here and a 3 here. So we would have 15 over 2 x to the power of a quarter. Okay, so this will be our answer for the expression, which is 6x to the power 5 over 4, and the derivative will be 15 over 2 x to the power of a quarter, which will be our answer for part E.